In this video, we're going to talk about power series. If x is a variable, then an infinite series of the form summation of n equals 0 to infinity of a of n x to the power of n equals a of 0 plus a1 times x plus a2 x squared plus so forth is called a power series. More generally, series of the form summation from n equals 0 to infinity of a of n times the quantity x minus c to the power of n equals this expression is called power series centered at c, where c is a constant. So both Taylor series and Maclaurin series are part of power series. So if you look at this power series, the center is at 0. And for this power series, the center is at -1. And for this power series, center is at +1. Now let's talk about convergence of a power series. For a power series centered at C, precisely one of the following is true. The series converges only at C, only at its center. There exists a real number r greater than 0 such that the series converges absolutely for absolute value of x minus c less than r and diverges for absolute value of x minus c greater than r. The series converges absolutely for all x. The number r is the radius of convergence of the power series. If the series converges only at c, the radius of convergence is r equals 0. And if the series converges for all x, the radius of convergence is r equals infinity. The set of all values of x for which the power series converges is the interval of convergence of the power series. Let's find the radius of convergence of this power series. First, what is the center? Center is at 0. And any power series converges at its center. Now, in order to find the radius of convergence, what you want to do is you want to use the ratio test. So what is a of n? A of n will be n factorial times x to the n. What about a of n plus 1? That's going to be quantity n plus 1 factorial times x to the n plus 1. So using the ratio test, limit as n goes to infinity of absolute value of a of n plus 1 over a of n, we get limit as n goes to infinity of absolute value of this, and then when you simplify this, quantity n plus 1 factorial is same thing as quantity n plus 1 times n factorial. And that becomes x to the n times x. All over n factorial times x to the n. Well, these two cancels out, and n factorial cancels out. Now notice, as n goes to infinity, this goes to infinity. It doesn't matter what x is, this whole thing goes to infinity. And you know that infinity is greater than 1. So by ratio test, this power series will diverge, except at its center, which is 0. Since this power series only converges at its center, the radius of convergence is 0. Now let's take a look at this power series. First, what is the center? Center is at 2. Now A of n is 3 quantity x minus 2 to the power of n, and A of n plus 1 is 3 times the quantity x minus 2 to the n plus 1. Now let's use the ratio test to find the radius of convergence. So you get this. After you simplify, you'll get limit as n goes to infinity of absolute value of x minus 2. Now notice, we don't have any n. So as n goes to infinity, limit as n approaches infinity, you just get absolute value of x minus 2. Now you know that this will converge only when it's less than 1. So take a look at this. By definition of convergence, you know that absolute value of x minus c is less than r, and this number represents the radius of convergence. So we have x minus 2, x minus c has to be less than r. So this, in this case, the radius of convergence is 1. So therefore, r is equal to 1. So in other words, let's look at the center. Center is at 2, right? So you could go 1 to the right, which is up to 3, and 1 to the left from the center, which is down to 1. So from 1 to 3, we know that this series, when x is from 1 to 3, this series will converge. But we need to wait until later to check the endpoints. But we know for sure from 1, any number from 1 to 3, between 1 and 3, will make this series converge. Meaning that this series will have finite sum whenever x is between 1 and 3, since radius is 1. Now let's take a look at this power series. Where's the center? Center is at 0. And A of n is just negative 1 to the n, x to the 2n plus 1 over quantity 2n plus 1 factorial. And what is A of n plus 1? Well, instead of n, we got to plug in n plus 1 now. So you get quantity negative 1 to the n plus 1 times x to the, instead of n, put n plus 1, and you will get x to the 2n plus 3 over, plug in n plus 1 over here, you get quantity 2n plus 3 factorial. So now let's use the ratio test. Limit as n goes to infinity of absolute value of is going to be A of n plus 1 over A of n. So it will be this divided by this, which is same thing as this multiplied by the reciprocal of that. So you end up getting this. Now we need to simplify this. By the way, both of these two are sign changers, and when they're in absolute value, it doesn't matter whether they're negative and positive, because they will end up being positive since they're both inside the absolute value. So we could ignore the sign changer, and you get this. I got these two from x to 2n plus 3, and I got these from quantity 2n plus 3 factorial. Think about it. This is going to be same thing as 2n plus 3 times 1 less than this, which is 2n plus 2, times 1 less than this, which is 2n plus 1 factorial. And I got these two from here. So we could cancel out these two right here. We could cancel out the x to 2n, cancel out x cubed and x. You are going to get x squared, and that cancels out. Now as n goes to infinity, well, notice the bottom goes to infinity, so it's going to go to 0. It doesn't matter what x is. Since n is approaching infinity, the bottom gets bigger, so the whole thing goes to 0. And you know that 0 is less than 1. So what does it mean? By ratio test, this series converges no matter what x is. It doesn't matter what x is. The series will always converge. Therefore, the radius of convergence is infinity. Think about it. Where's the center at? The center is at 0. There is a center. So it doesn't matter what x is. Radius of convergence is infinity. So equals infinity, positive direction, and negative direction. So domain of this power series is all real numbers.